This is the second part of 7-3, and in here we're continuing with the rest of the examples, and what we're talking about is the sample size for proportion. Sample size is knowing the error that you're trying to make, or that you're allowed to make, not trying, that you're allowed to make. Can we figure out the number of people that we need to survey? So how many people do we need to call with a yes or no question such that I will not, so my sample is what's called quote unquote large enough. The formula is given by p hat, q hat, z alpha over 2 over e, and that part has to be squared. This comes from the fact that the error is found, and I'm going to scroll up to my formula. That's that margin of error. All we're taking is this. This is my e. I'm going to get a bigger point. This is my margin of error. This is my e. All I did is solve for n. This formula will be given to you on the test, along with the z-scores that correspond to different intervals, and a few other formulas that we might need for the next test. But the example that I'd like to do is in the book. This is your example 7-11. And it says a researcher wishes to estimate with 95% confidence the proportion of people who will not have a landline. A previous study shows that 40% of those interviewed did not have a landline phone. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. So I'm going to start highlighting things. We have 95% confidence. The previous study showed that 40% of those who interviewed had a landline. No, did not have a landline. So this is what I'm going to do. People who did not have a landline. That's my success. So apparently 40% of those fall under that category. So what this is my p hat. 0.40. The end is what I'm looking for. So if I'm given a p hat, I can automatically find the q hat. So if 40% did not have a phone, that means that the other 60% still do. Let me put a 0 right here. The researcher wishes to be accurate within 2%. So this 2%, that's my e. So let's start putting this formula together. N is equal to p hat, which is 0.4, times q hat, which is 0.6, times the z alpha over 2 that corresponds to the 95% confidence interval, is 1.96, and those will also be all given to you. E is 0.02 squared. So all we're really doing is we're putting all of this into your calculator. 0.4 times 0.6 times, I'm opening parentheses, putting 1.96 over 0.02, and then I need to square whatever is inside the parentheses. The number that the calculator spits out is this. Very important. Always round up. Doesn't matter. Could be 2304.01. You will still round up. So the n that is necessary for this particular situation is 4,305 people. So this is how you would write this down. I always need a sentence for every single problem that is in chapter 7. 3,000, 2,000, I'm sorry. Let me write this down. People are needed in a sample. I'm more concerned with units, the fact that we are talking about people. Okay. Now, to finish this set of examples, I'm looking at example 7-12, which basically says I have exactly the same setup. I'm talking about the same landline. I'm still looking at 95% confidence, except and the error of 0.02, except I did not have any information about previous studies of anything. So if no previous studies is done, you want to be the most conservative, and you will use p hat is equal to 0.5 and q hat is equal to 0.5, meaning you have no idea how it's going to go. So it's a 50-50 flip. This will give you the most conservative answer. So once you put this all into your calculator, you have 0.5 times 0.5, and then the z is still 1.96. The error is still 2%. You're still squaring this. So if you type all of this into your calculator, you end up with, so I'm changing this to 5 and 5, you will end up with 2,401. So this one did not need any rounding at all. This is a weird coincidence, but notice that if we have no previous study, we actually need to ask more people. So 2,401 person is needed in the sample, or for this sample. On my next video, I will show you how to do all of this on your calculator.